All right, we're getting started with page 2 of the Unit 11 Algebra Review. We're only going to do evens this video, but hopefully that will help. This next section on your review is all about adding and subtracting your radicals. And so what you want to do is there's two specific steps you want to take yourself through. Number one, make sure your radicals are in simplest form. Simplify radicals. Then your last step is to combine like terms. The only radicals that can combine are the radicals that have the same number inside radical jail. So if we look at our first example, we're going to look and make sure that all of our radicals are simplified. I know that radical 6 can be broken up into a 2 times 3, but there are no buddies there that can come out, so he stays the same. Then I've got 7 radical 2, that's simplified because 2 can't be broken up. I've got 4 radical 2, and that's simplified. So now I look for like terms that I can combine. Look for the number under the radical. I've got a radical 6, a radical 2, and a radical 2. These guys are the same, so they can be combined. You don't combine the actual number in the radical, you just look for the like ones and then combine the numbers outside. So for instance, here we've got negative 7 radical 2 plus 4 radical 2. So negative 7 plus 4 is negative 3 radical 2. That radical 6 is still there, he's just right next to him. Okay? I tell my students a lot, this is the same thing as, let's say, the radical 6 was a y, and then I had negative 7x plus 4x. This is what we did in the very beginning. We can combine these like terms, but you can't combine the y. Okay? So that's what it's kind of like. You combine your like terms. Let's look at number 20. I've got 11 radical 3, 9 radical 3, and negative 3 radical 6. All of the numbers under my radical are simplified, so I go to step number 2, combine like terms. I've got radical 3 and radical 3, so I know that those can combine. So I combine the numbers that are outside of radical jail. 11 plus 9 is 20, radical 3, and then that negative 3 radical 6, he just tags on to the end, like that. Number 22, same thing. You want to make sure your radicals are simplified. Here, my radicals are not simplified yet. So I'm going to do this work on a separate sheet of paper because it takes a little bit more work. You've got radical 50. So we're going to simplify him first. Radical 50 breaks up into 2 times 25. 25 can be broken up into 5 times 5. Circle your buddies. I've got 2 5s here that get to come out. 1 5 stays right outside of the radical jail. 1 goes away, or goes home. And then the 2 is stuck right there in jail because he doesn't have any buddies. So instead of writing radical 50, I get to write 5 radical 2. Then I'm going to break up 3 radical 75. I can break up the 75 into 3 times 25. I can break up the 25 into 5 times 5. These are buddies. They get to break out of jail. And whenever you have somebody that's already outside of jail and you're bringing another number out, they multiply and stay out. So 3 times 5 is 15. And then the 3 is still in jail. So instead of 3 radical 75, I get to write negative 15 radical 3. That last step, the 3 radical 27, you want to make sure he's simplified. I know I can break up the 27 into 3 times 9. 9 breaks up into 3 times 3. So I've got buddies here that get to come out. They multiply with that 3 that's already out, and you get 9 radical 3 minus 9 radical 3. So I simplified those, and now I want to go to step number 2, combine like terms. I've got radical 3 here and a radical 3 here. So negative 15 radical 3 and a negative 9 radical 3 is going to combine to a negative 24 radical 3. It cannot be combined with this 5 radical 2 because it's a 2 in jail instead of a 3. So he just tags on to the end. And that would be your final answer. For the next section, we are solving each equation. Notice, in all the problems we've done so far, the radical has already been in the problem. He was already there. I didn't write him in. For this next section, I'm going to have to write the radical. And whenever you write it, you always want to add the plus or minus symbol. Okay? And we talked about how in class that's going to give us 2 separate answers. So, let's look at number 24 as a good example. In order to get x by himself, you need to do the opposite of the square, which is square root. And whatever you do to one side, you have to do the other. So you get, this cancels out the square, and you're just left with x equals. I have to write plus or minus square root of 72. From here, you always want to check to make sure that your radical is simplified. Okay? Can I break down radical 72? Yes, I can. What I want to do is work this on a separate sheet of paper, so I have plenty of room. Radical 72 breaks down into 8 times 9. 9 breaks down into 3 times 3. 8 breaks down into 2 times 4. 4 breaks down into 2 times 2. Circle your buddies. Both of these guys get to come out of jail. Remember, when there's 2 numbers outside of jail, they multiply. So 2 times 3 is 6. And then if you look, the 2 is the only guy that's left in jail. So radical 72 is the same thing as 6 radical 2. I'm going to rewrite my answer. X equals plus or minus 6 radical 2. Okay. Number 26 is a little bit more complicated. I started number 24 with the x squared by himself. So I knew that I could go ahead and just square root both sides in order to solve. But number 26 has a 6 right next to the x squared. So I have to get rid of him first. If he is being multiplied by the x squared, then in order to cancel him out, I can divide by 6. Cancel, divide by 6 on this side. X squared equals 7. 8. 6. 4. It's early. From there, you want to take the square root of both sides. X squared, cancels out the square, and you get square root of 8. Make sure you write the plus or minus. Okay? From there, you want to make sure this is simplified. Radical 8. So he breaks up into 4 times 2. 4 breaks up into 2 times 2. Circles. So x equals plus or minus the square root of 2 radical 2. Sorry, that's a little messy. I should have done that on a separate sheet of paper. So number 26, it would look like x equals plus or minus 2 radical 2. For our next problem, we want to get that x squared by himself, so you got to get that 1 away. So you would subtract him, cancel, minus 1 from this side. X squared equals a negative 1. Then you would square root both sides to cancel out the square. You get x equals plus or minus the square root of -1. Now we talked about in class how you can never have the square root of a negative. So from here, you would write no solution, because the square root of a negative number will never happen. Alright? Well, I hope that helps, guys. If you have questions, please come see me in tutoring Friday morning, okay?